For today's lesson, we're going to be talking about rate of change, better known as the slope of the line. The slope m of a non-vertical line is the number of units that the line rises or falls for each unit of horizontal change from left to right. You'll hear expressions like it's the ratio of rise over run, or it's the vertical change over the horizontal change. When talking about slope, people will use the word slant, the steepness of the line, and the rise and the fall. When we're dealing with linear equations, there are four representations that we'll be looking at. There'll be the positive slope that rises from left to right. There'll be the negative slope that falls from left to right. When there is no slope, we call that the zero slope, and the zero slope will definitely have no incline or decline, and we remember the z in zero with the zero on a horizontal. Good way to remember which is which, because the line that is undefined is called the vertical line, so that vertical line is undefined. And there we have the four basic types of lines and their slopes. So how are we going to identify the slope? Well, what if we're given the graph of this line already? Well, we have a way of calculating slope without using the slope formula. We're going to count boxes, and we're going to make what we call a slope triangle, and we're going to highlight the rise over the run. So let's take a look at what this looks like. I'm going to be counting again boxes, and when I look at this, I'm going to notice right away that this is going uphill, so it's a positive slope. I'm going to count the boxes up, 1, 2, so that's my vertical change over 1, 2, 3, and 4. So that was a up 2 and over 4. Let's see that again. It goes up 2 and over 1, 2, 3, 4, up 2 and over 1, 2, 3, 4. So again, my slope is a ratio of rise over run. This one can be simplified to 1/2. A second example. When I'm going to calculate from a line that's already graphed, I'm going to use points on that line, and those points will be at the intersection of two crossing lines. So I'm noticing that this one is different from the previous because it's now going downhill, so this has a negative slope. Right away, I can identify that by just looking at the picture. So one thing we can tell right away without any calculations at all is whether it's positive, negative, zero, or undefined. Now for the actual number. I'm counting down 1, 2, and over 1, 2, 3. It was again down 2, that makes it negative 2 over 3. Let's just check that again. It goes down 2 and over 1, 2, 3. And as we said earlier, slope is constant. Taking a look at a third example of calculating slope given the graph of the line, we'll pick a point where the lines cross or intersect. Then we're going to count up 1, 2, 3, and over 1. 1, 2, 3, and over 1. This is a 3 over 1 ratio, and so my slope is equal to 3. And we can do many more examples, but just to get a sense of how you can calculate slope from a graph, when I asked another class their comments when I asked them what slope was, I heard steepness, slant of a line, incline, decline. I was told that slope is constant, which we just proved. And over there on the left is that slope-intercept form of line, which we'll be using quite a bit. So as I'm looking at this, using some of the terms from the previous slide, slope is constant, so that I can keep using that ratio to find additional points. If it's going uphill, it's positive. I'm going to count up 1, 2, 3, and over 1, 2, 3, 4, 5. So my slope is a positive 3 over 5 ratio. And we can do some others in our session today. So I'll leave a few more for us to try. But now I want to get to using our slope formula. Actually, before we do, I forgot I had the two special types to share with you. When I see that horizontal line, I know that the slope is 0, and that tells me that y is constant, and we talked a little bit about that last session. And I also have that vertical line where the x is a constant, and that would be the undefined slope. Now, if I'm not mistaken, we're on to the formula. The formula is this change in y over change in x, and change is finding the difference. So we're going to have this formula, y2 minus y1, and those subscripts just refer to one point or another. So as I give you 2 points in my first example, I see that I have also above it labeled them, because some people like to have that as a reference, especially when we're starting. It's critical that we put the y2 minus y1 in the correct place, as well as the x2 minus the x1. And then we go ahead and simplify, and we get 6 over 4, and we'll simplify that again, dividing them both by the common factor of 2, and there's my slope. M is equal to a 3 over 2 ratio. That would go up 3 and over 2. We need to do several just to get the hang of this, and I'm sure everyone here has calculated slope before. I have 10 minus 4 over 1 minus a negative 2. Notice the placement of my negatives because I have to remember my rules of dealing with real numbers. I have 6, add the opposite over 3. This is a 2 to 1 ratio, and we can simply say that the slope is equal to 2. I have many examples for us to try out in class today. Let's just do perhaps 1 or 2 more. We'll go on with this one, and we'll see that slope, we always say that we're dealing with m, is equal to negative 10 minus 8 over negative 2 minus a negative 4. Placement is important, as well as the calculation or computation. This gives me negative 18. Add the opposite. That gives me negative 2 plus 4. It's going to give me 2, so m is equal to negative 9. And we can continue to try these other examples. You can try this one, and we'll go over the answer in class. And then we have, as always, ones that are a little bit different. So let's take a look at 1 or 2 last ones before the end of this session. And let's just start with, let's do the one on the right. M is equal to 5 minus 5 over negative 2 minus a negative 6. Well, as I'm simplifying, I get 0, add the opposite over 4. This tells me that my slope is equal to 0. When you're solving them and you get 0 as that change in your y, you must write that m is equal to 0. Yes, it's 0 over 4, but you need to be sure that you tell me that this slope is 0. And then I believe the final one for our session today will be this problem here. We'll have m is equal to, notice I'm always identifying what I'm solving for, negative 8 minus negative 5, and my change in x is 7 minus 7. Go ahead and add the opposite. That's going to give me negative 3 over 0. In this case, m is undefined. We can never divide by 0, and when we see these later on, we're going to see that this will form that vertical line. And that's all I'm going to do for our video lesson, but we'll certainly do more in our Zoom class. See you then.